Hello everyone, I hope you can hear me well. If you can hear me, just give me a sign. My name is Yvette and I'm the marketing manager of StorPool Storage, and I'm happy to be the moderator of today's webinar. The topic of the webinar is building a large-scale infrastructure as a service with CloudStack and software-defined storage. The webinar will be approximately 50 minutes and we will have an exciting Q&A session at the end of the event. So be sure you're staying here together with us till the end of the event and ask your questions. We have two speakers today. The first one is Venko Muyankov, who is a solutions architect at StorPool and who will share a little bit more about CloudStack, building infrastructure as a service, and the storage challenges which you can meet. And our guest speaker today is Simon Utting, who is the CEO of Amito. Simon will share a little bit more about their success story of building a reliable, scalable infrastructure as a service with CloudStack and with StorPool storage. And before we start with today's webinar, I will just launch a poll with two questions which we have prepared so that we can better understand what is our audience. Hope you can all see the poll. We have just two questions for you. Which cloud management system are you currently using and which storage system are you currently using? And we will be happy if you can share your feedback. We can see Simon now. Hi, Simon. And a few organizational things. During the webinar, you can share your questions on the chat window. I will try to ask all of the questions at the end of the event. Venko?
Hello. Hello, everyone. So today we'll talk about common challenges when building large-scale infrastructure as a service clouds. And we'll go in more details how the combination of CloudStack and StorPool can help solving these problems. We'll also see some of the important things to be considered when we start such a project. I hope that this information presented today will help not only for those who will build new clouds, but also will be useful for operators of existing clouds and virtualization infrastructures. So building an infrastructure as a service is a complex process which requires careful planning, and the final result depends on the initial preparation. When you need to build an infrastructure as a service, you first need to answer some of the questions. What is the workload? What capacity do you need to start with and how to scale? What the hardware and the storage you use? What cloud orchestration system to use? And how to implement, manage, and operate the entire cloud infrastructure. When you start such a project, there are several challenges. Most of these challenges are common for almost every project. Today we'll talk about some of the most common challenges. The first one that we'll discuss is reliability. When you build a large-scale infrastructure, you expect that this infrastructure will have much higher reliability than traditional small-scale infrastructure. On the other hand, with a large scale comes additional complexity that adds more components to the critical path and makes it more difficult to achieve certain level of reliability. Another common challenge is complexity. Increasing the size leads to increased complexity. This applies to all type of elements in the cloud, to the compute nodes, network, storage, orchestration system, monitoring operation. For example, if you have a small scale system, you can put all the hardware that you have in one rack, and you can build a network with your network with just 2 top of rack switches. However, if you increase the scale, you need to build much more complex network that shall provide high bandwidth and reliable connectivity between multiple racks located on different rows or even in different rooms in the data center. One of the very common challenges is limited scalability. So every solution has some limits, but many solutions that have limits that are just not suitable for large-scale deployments. So you have to select a solution that can be properly scaled. Otherwise, using not a solution that cannot scale well will bring additional costs because of the not optimized operation and additional complexity. Low performance, this is maybe the most serious challenge that need to be addressed when you build large-scale infrastructure. The typical reason for low performance is the bottlenecks in the network, in the storage system, and the orchestration systems. Some challenge that you may find in some project, if you have to support multiple stacks, is the lack of multi-stack support. Typically, if you need to support multiple different stacks, you don't want to have separate clouds, one for Linux workload, one for Windows workload. So you need to select hypervisors and orchestrators that can handle all type of workloads. And when we're talking about workloads, it's not only the guest operating system, but the different type of hypervisors that are supported by the cloud. Vendor lock-in is a problem for any scale project, but with a large-scale infrastructure, this could be a serious financial problem, as it is related with large investments in hardware, software, and stuff. And refresh cycle, this is again usually related with the vendor lock-in, but this is something that is very often overlooked. It's important that after a few years of operation, the system that you have will allow hardware to be gradually replaced and not require to replace the entire system at once. Replacing the entire system at once means usually increased cost, increased operational complexity, and in many cases, downtime. Also, when we're talking about refresh cycle, not all parts of the system have the same lifetime. The typical example are the traditional storage system. When, for example, the old storage system can be completely usable, but there is no feasible option to upgrade the product because there is a new generation of the product on the market now. And this usually requires replacing the entire storage system and replace it with a next generation product. The ideal solution would allow you to replace the hardware gradually and to mix the different generation of hardware in the same system. This would allow old components to be gradually retired only when they are no more economically viable, and don't force you to decommission equipment that still can generate revenue. And one more thing about the refresh cycle. Think of the refresh cycle not only at the system level, but at the individual component level. For example, does your several years old storage system allows you to use the latest generation drives available on the market? And the reverse direction, does your brand new storage system allows you to use your existing drives from your old system? So there are several options to address these challenges. And now we'll discuss the CloudStack as an orchestrator for large-scale infrastructure as a service cloud. So every cloud has pros and cons, and every cloud addresses the challenges we discuss in different way. So there is no single solution that can fit in every possible use case. But the features and capabilities of CloudStack make it a very good fit for many large-scale infrastructure as a service project. So we'll go through some of these features and see how they fit and how they answer the needs and address the challenges. First, CloudStack is an integrated product specially designed for infrastructure as a service clouds. This makes it simple to deploy and operate, while at the same time it provides the features that are needed by most operators out of the box. The most popular alternative, OpenStack, is actually not one single product, but an ecosystem of different projects that can be combined to build a system for specific use case. So this makes the deployment, every deployment unique, and the implementation project very complex, difficult, and usually very expensive. In contrast, deployment of a CloudStack orchestrator is a straightforward process, and even the simplest deployment that provides only out-of-the-box feature in the CloudStack is completely adequate for production use. Hardware and hypervisor support. CloudStack can orchestrate simultaneously a broad range of hypervisors. The most popular is KVM, but also you may have in your infrastructure Zen Server, VMware, Microsoft Hyper-V. CloudStack also supports bare metal servers and LXC containers. So with this, you can have a one cloud that can cover multiple use cases for your customers. And CloudStack is designed for large-scale deployments in mind. While it can be successfully used in small deployments due to its simplicity, the real strength of this system shows that really at large scale. The largest known production cloud consists of more than 35,000 of physical hosts. So this diagram is familiar to many of you. This is the hierarchy of the resources in CloudStack. CloudStack is built with the concept of hierarchical structure of zones, pods, clusters, and hosts. The controller is highly efficient and capable to manage thousands of hosts. And for even larger deployments, it supports load balancing of multiple management nodes. CloudStack comes with a ready-for-use web interface for administrators and for end users, with a command line interface and with a very rich REST-based API that allows building sophisticated integration with third-party system and to automate many of the tasks that you have in your cloud. CloudStack has a very rich virtual networking that includes probably all the features that you need out of the box, including virtual routers, firewall, and load balancers. And because CloudStack is an integrated application with high performance, the implementation is very simple. The operation is much simpler compared to other products. So the result is lower implementation and operating costs. And last but not least, CloudStack is open source with a open source project with constant development and with a very active community. And it is a community-driven project, which means that the development is focused on the actual needs of the users. The next important part in your cloud is the storage system. So we will discuss here software-defined storage, and while software-defined storage is important, to use software-defined storage in your cloud is so important because of many of the features of SDS. While not software-defined storage systems are equal, many of them share features that are preferred solution for large clouds. When you're looking for a solution, pay attention if it can provide all the features that you need in your cloud, and we'll see here some of the most important. So one of the very important characteristics of most SDS solutions is fully distributed architecture. While some SDS are built as a centralized controller with attached disk arrays, and they operate in general similar to a traditional SaaS storages, they usually cannot provide enough performance and cannot scale well. However, most of the modern SDS solutions are fully distributed, and some of them are built on share nothing architecture that allows them to scale very well, both in terms of capacity and performance. The distributed architecture also means better reliability and, what is more important, greater flexibility for operation and maintenance. Distributed system allow uninterrupted operation during maintenance. You can stop only part of the system for the maintenance, while at the same time the functionality is preserved, possibly with some reduction in the performance. This way you can do in-service software upgrades through in-service software upgrades, or even hardware refresh cycle without 1 second of downtime. This not only eliminates one of the main sources of downtime, the maintenance windows, but also this significantly simplifies the operation, and the complex operation is prone to human errors. That is another source of downtime. Ability to easily scale the storage system at any time helps a lot with precise planning. Now you don't need to plan in advance the hardware for months or even years ahead, as you have to do this with the traditional sign-based storage systems. This means that you can better utilize your existing hardware and not to buy hardware that will not be used the next, let's say, 1 year in the beginning of your project. Better hardware utilization means reduced hardware cost and reduced operating expenses. Another great advantage is the vendor independence. There are several things here. First, you can use the hardware from your preferred server vendor, select from a wide variety of servers and components that best fit the task, and get the best possible prices. But more important is that you're not locked into the same vendor once you buy something. You can always take advantage of the fair prices and the latest technology that are available on the market. So with this, I would invite Simon with their success story, how they built their large-scale infrastructure as a service with CloudStack and StorPool. Simon?
Thank you very much, Venko. I'll just share my screen quickly so that I've got control of the slides. 1 second. Okay.
We can see your slides now.
Great, excellent. So yeah, thank you, Venko, and yeah, thanks everyone for joining. Hopefully, I can talk you through a little bit about our experience with CloudStack and StorPool, and hopefully there'll be some value in there for people listening. So the first couple of slides that I want to go through are to set the scene a little bit. I appreciate no one really wants to join a technical webinar and have a sales pitch. That's not what this is about. It's just about explaining how we provide services so that you can understand the basis of our experience and how that might apply to whatever kind of infrastructure you're building and how you're using CloudStack. So the key thing about us, we've now been in the industry for All the senior team have now been in the industry for about 15 years. And we have built up the cloud side of our business basically since 2011, which was a very different world compared to now. I'll come back to that a little bit later when I come back to talk about CloudStack. But the world at that point was very, very different. We originally started out building the cloud side of the business. We then built a data center here in Reading, 60,000 square foot site. But we've now got a co-location presence across multiple data centers in the UK. So that's London, Slough, Manchester, and across the world. And we specialize in hybrid systems. So our ability with co-location and actual data center space all the way through sort of public cloud on this scale, and also doing private cloud as well, so slightly smaller scale deployments. So I'm the COO. I run the technical side of the business, so that's everything from support, operations, and also, importantly for this webinar, the infrastructure. So that's what we use internally, but also what we provide to clients. In other businesses, I've run the sales side of things. I ran the support teams for a previous business that did, at its peak, 6,000 physical servers. So hopefully the experiences that we've had here and my experiences in the past will help to provide a little bit of background and experience. So how do we provide cloud services? I'll briefly just explain. So one of the core values that we have is excellence, and the only way that you can deliver that is through providing the right technical solution, and that does often require different infrastructure for different needs. So we have a range of different services, and public cloud obviously is at the top there. We do public cloud in the CloudStack model, so we have large pools of resources, and then clients will get a subsection of that pool, and then from within that they can build whatever instance sizes and types they want. We don't have fixed instance sizes, and we can, as a managed services provider, we can then apply underneath that very effective support because we have very deep technical knowledge. And the important thing with that is to not rely on getting to the point where you've already deployed your infrastructure and you're supporting clients from it, and then look to solve any problems that come up. You need to make sure that you, as Venka was saying, take into consideration at the start what the problem is that you're trying to solve and what type of solution you're going to need. In terms of customers, we serve a very big range of customers, and that's across lots of different verticals. So there's no one particular industry that we're tied to, but what we definitely see across everything is that there's a very common type of system. It's a database-driven web service of some form, whether that's HTML, Apple, or API front end. There's going to be a database at the back, and if there's a database pulling data and writing out data, then the storage is critical. It's still the most important aspect of the system, and that's consistent across all the different cloud types that we do, whether it's large-scale public clouds, and we've got VMs running on our cloud, or whether someone's actually designed a private cloud to serve a particular system. It's probably almost certainly going to be still a database-driven system at the back end. So what do we do what do we think are the important things when we're talking about a cloud platform solution? So orchestration and automation are going to be the key things to be competitive. But I think the important thing to understand is don't try to do everything perfectly on day one. I think there's an awful lot of what Venka was laying out at the start there are really, really important considerations, and you need to give some careful thought to what you're starting with, but then be prepared to evolve on that. Be prepared to set yourselves up in a way where you can adjust as you go through. You can't necessarily do everything and perhaps learn all the lessons that we have in 9 years overnight, but hopefully you can learn a little bit from our experiences. The goals that you have for your infrastructure platform will be different from ours, and you've got to work out what those key things are that you're trying to solve first of all, design to that, and then perhaps in the future move on to improve on those. So we have been through and designed our platform. We've got our compute, we've got our storage, we've got our network, we've then got virtual machine solutions around that. But what we're now most concerned about, and have been for the last couple of years, is how do we automate that? So Ansible for all of your infrastructure. If you can start off with that, that's a much better place to be. So try to make sure that you're deploying everything in an automated way. It's controllable, it's error-free. If you can automate your VM templates, it's a complicated and difficult subject, but we can run a script that builds a Windows virtual machine from basic install, applies all updates, and then completely configures it the way we want it, and then spits out a VM image at the end. And the same for Linux and other types of OS. Definitely make sure that monitoring and possibly even centralized logging is a key part of what you're doing, because if you can't see where the problems are as your infrastructure grows, then you're not going to be able to solve those. The final point is around support, and that depends what sort of infrastructure that you're building. So if it's for internal use, your approach to support might be slightly different, but as a managed services provider, our support is direct to clients, and it's a key thing. Always try to use it's basic scientific method, I guess, is what we try to do, which is reproduce the problem ourselves, generate some data from that problem, some numbers, apply whatever change it is that you're going to try, and then generate more data, and then iterate over that. It sounds very simple, but if you're not sort of set up to try and do those processes when those problems hit you, you will then be scrabbling slightly more to try and deal with those situations. So make sure you get that in place. So this is a quick slide showing a diagram of our Gen 4 infrastructure. So our first generation was in 2011, Gen 2 in 2013, Gen 3 in 2017, and Gen 4 went live in 2019. I think the key points, and Venka mentioned this as well, is scale is everything, and always try and make sure that you're building to the right scale. So for some of our public clouds, the right solution is that we keep everything within a rack. And we, through many years now, 15, 16 years of being involved in building infrastructure platforms, networking is one of those things where if you can keep it small, keep it small. So we try to keep networking within a rack where we can, and if we do that, then a rack becomes a zone because of the way that CloudStack networking works. So we're a Juniper house, so when we were doing Gen 4, we wanted to go to 25 gigs, so there are QFX switches in there. The Gen 4 platform is KVM hypervisors. We moved from Zen server to KVM. And the storage is, we moved from VHDs on NFS from ZFS to StorPool. And then on top of that, we customized that a lot. So the actual virtual machine layer, we've got load balancer appliances and VPNs. We've got various other appliances that we tie together as building blocks to make a customizable, complete service. But the underlying infrastructure there is what we build on. So you can see two compute clusters, sorry, 16 nodes, 32 GB of space already, three nodes of StorPool. Some of them are obviously going to be bigger than that, but one of the great advantages of scale out is that we can just add more nodes as we need to. There's a bit of additional networking in there, but one of the other things that we've chosen to do is we keep all our CloudStack infrastructure in a different location to the actual cloud platforms, and then we connect that back to each location, usually over IPsec VPN tunnels. I've cheated a little bit and simplified the actual network that the data center and across the UK that we use to actually connect into the internet, but that's a slightly different subject. And we make use of StorPool solutions for replicating data off-site. We had invested quite a lot of time in building our own solution before moving to StorPool, and some of the features that weren't there, they added, and we've really enjoyed working with them to try and build those sorts of solutions out. So I'll move on to talk a little bit about why we're using CloudStack. See, one of the key points of the webinar. back in 2011, when we were first building out our cloud platforms, as I said earlier, it was a pretty unrecognizable cloud landscape. AWS existed, and to be honest, that was pretty much it. Obviously, there were other providers out there, but that's really all anyone remembered. So what we also found was that clients were very resistant to cloud. What we would quite often hear is, "I don't want VPS," which fast forward to today isn't something that you would expect to hear. But what we found was we were quite often educating rather than necessarily straight selling. So it's a different problem now. But there were lots of things that we were trying to solve pretty much for the first time. They weren't off-the-shelf solutions. How do you do storage? There was no scale out, there was no object. How do you do the orchestration? Well, there was on-app, CloudStack, OpenStack. They all look very different to what they do today. We needed, as a managed services provider, we needed a portal. And so there were various off-the-shelf solutions. We have now got our own solution that we've built in-house. And we had I'm very lucky that one of my fellow directors, our head of systems, very talented guy, has built that system out with his team. So we now have a portal built in-house, but at the time we weren't in a position to deploy that in day one for the cloud side of the business. And so we needed something off the shelf. So we looked at all sorts of different things, host build, WHMCS, lots of different options. In 2012, when we were looking at orchestration specifically, because orchestration wasn't solving our problems, it was pretty much between CloudStack and OpenStack. So, and our experience, I think, ties in completely with what Benko was saying before. CloudStack had a UI. It was something that we could deploy that worked with the portal that we'd chosen at the time, and that we could deploy. Perhaps it wasn't quite as easy as it is now, but the headaches that we encountered, we could overcome pretty quickly. OpenStack was much more complex, much harder to deploy, and we needed to put more effort in initially to get things up and running. And for what we were looking to do at the time, there wasn't a huge amount of discernible technical difference between the two projects. We make a lot of use of the regions within CloudStack. So we've got our DC here in Reading, where we've got a lot of services, but Manchester, also in the UK, Frankfurt, we were in Atlanta, which is now New York, Australia, and other places around the world. CloudStack gave us the ability to manage all of that. The different network models are very important, especially when we're doing things with private cloud tied into public cloud. Some of our clients have very specific network requirements, VPLS, direct connections into their clouds that we needed to be able to support, L2 rather than just L3. We have now put a portal over the top of CloudStack, and I'm just going to quickly talk about that, because through adding that portal, we now have the ability to integrate with multiple CS instances, and obviously underneath that there are many zones, many different types of cloud infrastructure, but through one pane of glass. So I suppose it's important to make sure that you're making your decisions about what you might use and how you might use it, as much as anything about what CloudStack does well, but also what it doesn't do. For us as a managed services provider, we needed a way to present things to our clients. This screen is just showing two cloud-specific parts of the interface, and from the staff perspective, so slightly more detailed than perhaps what a client might see. But obviously you can see there a cloud platform and a cloud service, sorry, and that's a CloudStack service, and then the virtual machine that's one of the virtual machines within that service. What we've done is just to tie directly into the CloudStack API, wrap our interface around that, and then because it sits alongside everything else that portal does, it gives one pane of glass both for clients, which very useful for them to have that alongside ticketing, billing, and other types of services, so like co-location and things like that. But I could also heavily recommend that you think about how your staff, how you're going to be supporting this platform. Even if it's internal, there'll need to be support for it, how you're going to manage it, and any any additional features that you're going to need to add in. It might not need to be quite as comprehensive as what we've built. You can see down the side there that this interface, this portal, it's managing our Reading data center. So there's a building management system there. It does the ANPR for car visitors, access to the data center, all the 28 other data centers, the racks, assets, cross connects, subnets, DDoS protection, as well as the cloud orchestration that it then ties into. So there's a lot there. It's just one of those things that you need to think about. Is there additional tooling that you might need? CloudStack does a lot out of the box, but what will you need to build around it? Oh, and then so also the storage system, the second important part of the decision-making process that we went through for Gen 4. We've spent probably, of the 9 years that we've been building cloud platforms, I think storage has always been the key focus, and it's a challenge that we've solved very well, depending on the requirements at the time. When we got to Gen 4, I think our primary driver was really that we were achieving very high performance, but we were investing quite a lot of our own in-house resources to achieve that. When we were looking at how we might want to choose a vendor that we were going to switch to instead, there were a few different things that we needed to take into consideration. There's a few notes on that on the screen there, but I think ultimately for me, scale out beats SAN. The idea of an old style monolithic SAN doesn't really work. Obviously, yes, you can get good performance, but you can get good performance with scale outs. Why not object? If you look at the performance that you get from object-based storage systems, the performance just doesn't carry through. You may have other reasons for wanting to look at that, but we certainly didn't feel like it was a worthwhile pursuit. And then so we're focusing around scale out. Then how do we choose which of the scale out solutions we might want to go for? I think you can look a lot at capabilities and features, but ultimately it comes down to, if you pick a vendor based on the feature list, you're trusting that that feature list is going to be delivered. And as important to me is what happens when that feature list either doesn't work quite as intended, or you need to add to that feature list. As a company, we have a culture of continuously innovating and developing new solutions. When a client comes to us and asks for something, if we can't do it, we wouldn't say no. We'll always say yes, but then also try and work out the best way to solve that problem. So we've already built an awful lot around CloudStack. We've got a lot of tooling, Python scripting, the portal that I've already showed you, and various additional tooling, even so far as to tie into ZFS in a way that meant when we were doing restores, although CloudStack's got snapshots, it doesn't really deliver everything that we wanted to. And so we built a system that was scripted, that we could work on individual disks, so we could take an entire virtual machine, roll it back to a point in time, whether those images were held on the storage in Reading, say, or in Manchester, which is where they're backed up to. And we could run that VM from those images in Manchester, and then live migrate in the backgrounds. And working with StorPool, we came along with that requirement, and we needed to take the existing feature set. We needed to potentially add a few bits and pieces. Every time that we've had any requirement that wasn't already met, or we've had a problem, we've been able to engage with them. They've never held us up. They've usually gone away and solved it probably faster even than I was expecting. So I think that's a key thing to add alongside all the normal lists that you'll see about features and resilience and flexibility and performance. How is that company going to be the right fit for you to work with? So just to sum up then, I think our Gen 4 platform is probably the most stable and highest performance that we've built. It's definitely got the most features. And I don't think that we could have got to where we are today with something like 70% of our estate now on Gen 4. We couldn't have achieved building this Gen 4 platform, and we couldn't have migrated that many people to it with any other vendor. I've been very happy with our interactions with StorPool.
Thank you, Simon. It was really a pleasure to hear such kind words from your side, and we're very happy to have you as a customer. We currently have some questions on the chat. We will ask them at the end of the webinar. If Venko, you can also share your screen, and we have a few more slides in the webinar about why to choose a software-defined storage, and then we will go to the Q&A session.
Okay, so thank you, Simon. I'll continue with this a little bit more technical part. I'll try to cover it very briefly. So this part presents how StorPool integrates with CloudStack and the features of such integration. On this picture, on this diagram, we have a very simplified presentation of a cloud build of a CloudStack orchestrator, KVM hosts, and StorPool storage. So some components like virtual network are skipped for clarity. You can see here at the bottom in this green box, this is the StorPool cluster. It's built of several Linux nodes that runs StorPool server software. You have Linux KVM hosts running your virtual machines, and CloudStack orchestrators. So this integration is built on two main components. The first one is the client driver that is installed on every Linux host, and this allows this driver allows Linux host to access any volume on the storage system. Just like a regular locally attached drive. And the second component is the storage driver for CloudStack. So with this driver, CloudStack controller can manage the StorPool cluster and do all the tasks on demand. And this way you can avoid eliminate fully the need for manually administering the administration of the storage system, like for all the daily operations like creating volumes, resize, delete volumes, making snapshots, and so on. This integration provides many advantages. Having a deep integration enable CloudStack to operate in a way that every virtual disk has individual volume on the storage system. With this, CloudStack can, and using StorPool driver, can offload many of the typical tasks that are executed on the hypervisors to be offloaded to the storage system. And I'll give you two examples how efficient can be to offload some of the tasks to the storage system. The first one is when creating a virtual machine. Typically, creating a virtual machine involves creating virtual disks and copying the data from the template image to the virtual disk. When you have this deep integration, this task of copying the data and creating virtual disk can be offloaded to the storage system. So this way you can avoid this double transfer of data between the storage system and the hypervisor. But that is most important here because this is now done at the storage system. Storage system can do this much more efficiently because storage system do copy and write clone of the image instead of copying physical data from one volume to another. First, this makes this operation instantaneous. No matter how big the virtual disk is, creation of a virtual machine now takes only a few milliseconds. And the second one, this copy and write clones actually doesn't consume any additional space on the storage system when you create new virtual machines. This means that if you have hundreds of virtual machines created from the same template, there will be only one copy of the common files stored on the primary storage. This greatly reduces the amount of space consumed on the storage system and reduce the CapEx and OpEx. Another example is snapshots. So with this integration, traditionally snapshots are implemented using the QEMU process on the hypervisor. With this deep integration, snapshots are now offloaded to the storage system, and StorPool takes the snapshot of the volumes. This not only offloads the hypervisors, but again significantly improves the efficiency of this task. Snapshots in StorPool are implemented also with copy and write technique. This makes taking snapshots very cheap operation, both in terms of CPU, bandwidth, and storage space. So some interesting and some unique features of this integration between CloudStack and StorPool. I'll mention just a few of them. First of them is group snapshots. Group snapshots using a StorPool driver with CloudStack allows you to take a snapshot of multiple disks, all disks of a virtual machine to be done as an atomic operation. This means that all the snapshots are created at exactly the same point in time. And this is especially important when you have a database or any other application running in the virtual machine that stores data on multiple disks. So with atomic snapshot, you are sure that all the data across all the disks in the virtual machines is always in a consistent state. Disaster recovery. This is StorPool has some built-in features that can facilitate building disaster recovery infrastructures. Using these features, you can build a disaster recovery cloud or a DR zone in the same cloud, where you can keep a copy of your running virtual machines on your DR side. So if the main site goes down, you can spin off the virtual machines directly from the DR storage without the need to recover disks from backups. This greatly reduces the service recovery time and can increase significantly the total availability of the system. And the last feature that I would like to mention here is automatic backups. StorPool has a function of automatic backups. You can define backup policy, retention policy for different volumes. And this feature is completely transparent to the upper layers. However, it provides an interface so it can be easily integrated with a higher layer system, so you can manage the backups and do the recovery tasks. So with all this example, I would like to show that it is very important to have a feature-rich storage system that is well integrated to your cloud, and with this you can significantly simplify the overall design of the cloud and at the same time provide new services and reduce the total cost of the operation. So maybe to wrap up, the combination of CloudStack and StorPool is suitable for many use cases where high availability, high performance, and high scalability are required. Typical use cases are public cloud, infrastructure as a service, hybrid and private clouds. DevOps automation. One interesting case is combining cloud and virtualization with containers. Building Kubernetes as a service. This is possible with the new feature called Kubernetes service that was introduced in the latest release of CloudStack, the release 4.14.
Thank you, Venko. Because we're a little bit running out of time, at the last slide of this presentation, we collected some useful resources for all of our participants. We will send you the presentation after the webinar and hope you find it interesting. And now we go to the Q&A session. We already have some questions which are here in the chat window and a few questions from our Facebook live stream, but we also encourage you to write more questions if you have such. So I will start with the first question of Demeter, which is most probably to Simon. Which storage systems did Amito test it, and why you selected exactly CloudStack and StorPool?
Okay, yeah, I saw that question in the chat, and then immediately started racking my brains to try and remember all the names of the different vendors that we looked at. I mean, certainly the big players were in there, so EMC, NetApp. We also looked at Pure, I think, and a couple of others that were essentially, you know, more of a SAM type solution. There's options where you're tied very tightly to hardware, and we didn't particularly want to go down that route. We looked at some of the hyperconverged things like Nutanix. I think in the end, we've always operated in a non-hyperconverged route, and it doesn't work so well in our experience for larger scale infrastructure as a service. You end up with more compute than storage, and it just doesn't scale as well. It'll depend on the requirements. We also looked at some Ceph-based stuff, and I can't remember the name of all of the companies that we looked at. There were quite a few in that because we were seriously considering objects-based. Why StorPool? I think performance and you know, the flexibility of the scale out, and then ultimately there was some commercial decisions in there as well.
Thank you, Simon. The next question is from the Facebook stream, and it's a little bit strange. I will ask it. I think that both Simon and Venko should answer to it. The question is, how big can this solution become? In terms of scalability, maybe Venko can share a few words about StorPool storage, and Simon can give a real-life example about the size which maybe they're planning in the future.
Yeah, so CloudStack Cloud can be very large. The public information is for more than 35,000 of physical hosts in one CloudStack Cloud. Regarding StorPool, StorPool can start from, let's say, 10 terabytes, but that's not very economically effective, and it can grow to multi-petabytes. Usually, you would like, as Simon said, you'd like, if it's possible, to keep things simple and small within certain limits. So the most common practice with our customers is that if they need several tens of petabytes of storage, to split them in a smaller system that is that they will limit failure domain and availability zones, and that will simplify a bit the operation. So it's StorPool storage can grow really really big, but usually from the operation perspective, it's not a very good idea to have such a big cloud, such a big storage cluster.
Simon, would you like also to add something?
Sure. So I think it depends on your requirement. So as a managed services provider, we're going to be driven by what our clients need. We've got some clients that, for instance, do document management systems. So there's an awful lot of scanning of physical documents, and digitized things like that are going to take up a lot of space. So they're much more storage heavy. However, on average, the volume of storage requirement versus performance and versus compute resources tends to be relatively small. If we put 32 hosts at 300, possibly 400, possibly 512 gig of RAM per hypervisor into a single rack, then that's a lot of compute that you can put into a relatively small space. Obviously, we do get clients that need to grow beyond that, and so we tend to work on the basis of, well, the public cloud can support a certain level, and then if they need to go beyond that, we will either build out public cloud or we'll go private for them to meet those requirements.
Cool. The next question is also to Simon. It's coming from Paul Angus. Hi, Paul, and it's nice to see that you're here part of the webinar. As CloudStack is an open source solution, do Amito get involved with the open source community around it?
Yes, we have. So we've been involved in providing some code fixes to some of the virtual routers in the past, predominantly on the networking side of things, because that's, if I'm honest, that's where we've probably come up against things that we needed to solve that CloudStack couldn't do out of the box. So we have got involved in some of those things. I think a lot of our customization is probably quite specific to what we do, and so we haven't had as much opportunity to feed that back into the community. But we're certainly always looking to get involved and to feed back where we can.
Thank you, Simon. The next question is a little bit more technical. Does StorPool uses linked cloning for new VM disk creating using the same template?
So yes, you can say it's similar to link cloning. So when you create a new virtual machine, StorPool driver in CloudStack actually instructs StorPool, and it's a clone of this image created, and this clone is used as a root disk. So this is a copy on write clone. So all the write operation goes to the new volume, while reading from the common data that's from the template is coming from the template image.
Venko, we actually don't hear you.
Sorry. So yes, we are using clones when you're creating a new virtual machines, a new virtual disk from template images. So when a new virtual machine is created, the root disk is created as a clone of this image, and this clone is a copy on write clone. So all the write operation goes to this new volume that represents the root disk of the virtual machine, but reading from all the common data that comes from the image, from the template image, are actually coming from this template image. So you don't have a second copy stored on the primary storage.
Thank you, Venko. The next question is again to Venko, and it's coming from Mark Kamer. Some of the features of CloudStack with StorPool, are some of these also dependent on which hypervisor you're using, say only with KVM versus Zen Server?
Yes, most of the features that we discuss here are related to KVM. Zen Server has a very specific way that it is using data stores, and Zen Server is using IaaS interface. So Zen Server with CloudStack and StorPool is a fully supported configuration. We have such deployments, but in this case, Zen servers are connected to StorPool over IaaS interface, and this doesn't allow to leverage all the features that exist in StorPool.
Thanks, Venko. We have 1 minute more for questions, and one last question coming from Yosef Awani. If you just can give us some advice on how we can use CloudStack to create our own cloud business one day, what's the most important thing to know and to do actually? And I think that this goes directly to Simon.
Sure. I think it's a good idea, Yusuf. Go and give it a go. I think that if I was starting out now, then I would probably suggest that you approach things from a fully automated position. Okay, so choosing your hardware and choosing your orchestration, you want things to be as simple as you possibly can and make it as easy to maintain as possible, because frankly, you're going to spend most of your time selling. Because if you don't have any clients, then you haven't got a cloud business.
Yeah, that sounds like the real true. Thank you, Simon. We're actually at the end of this webinar. I want to say first a big thanks to Simon and to Venko for being our amazing speakers today and for sharing this success story of Amito. And also a few words about CloudStack. CloudStack is really a great technology and it's a user-driven technology and the community is really awesome. So you can stay tuned for next CloudStack events, which most probably will be virtual. And we will send you all the webinar recording together with the slides. You can write us at info@storpool.com. And if you have any questions either to Simon or Venko, we would help you or your questions getting answered. So thank you for being with us today. Have a nice evening to everyone. Bye.